You can also use the Pythagorean theorem to test a triangle to see if it truly is a right triangle. You know, in case you're not already sure. For example, what if someone shows you this triangle and asks, is this a right triangle? Well, it looks a lot like a right triangle, but it doesn't have a right angle symbol, and it would be kind of hard to tell if this angle is exactly 90 degrees just by looking at it. Maybe it's really close to 90, like 89.5 degrees. No worries, the Pythagorean theorem can tell us for sure if we know the lengths of all three sides of the triangle. If we know those lengths, A, B, and C, then we can just plug them into the Pythagorean theorem equation to see if it holds true. In this particular case, since the two shorter sides are each 3 centimeters and the longest side is 4 centimeters, we can plug those values in for A, B, and C and simplify to see what we get. 3 squared is 9, so on this side of the equation we get 9 plus 9, which is 18. And on the other side, we have 4 squared, which is 16. Uh-oh, that doesn't look right. Our equation simplified to 18 equals 16, which is definitely not a true statement. That means that the three sides of this triangle do not work in the Pythagorean theorem. They don't fit the relationship a squared plus b squared equals c squared. And since the Pythagorean theorem tells us that all right triangles fit that relationship, this triangle must not be a right triangle. All right, so now you know what the Pythagorean theorem is, and you know how to use it. You can use it to find a missing side of any right triangle. And you can also use it to test a triangle to see if it qualifies as a right triangle.
Hi guys, so today we're going to be going over the converse of the Pythagorean theorem, and just so we can tell the difference between them, let's go ahead and read them together. So the Pythagorean theorem states that in a right angled triangle, the square of the hypotenuse side is equal to the sum of the squares of the other two sides. So here the Pythagorean theorem tells us if we start with a right triangle, if we start with a right triangle, then we know that leg squared plus leg squared equals hypotenuse squared. The converse just means the other way around. So the converse tells us if the square of the longest side of the triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. So basically saying if leg squared plus leg squared equals hypotenuse squared, then we know that the triangle is indeed a right triangle. Wow, I cannot draw today. Well, there we go. So you can see that the converse is basically saying now we're going to start with this, and if this is true, then it will tell us that it is a right triangle. Okay, so let's go ahead and look some example problems. So the important thing that we learned from the converse is that the hypotenuse is the longest side of the right triangle. So we're going to assume that working with these triangles, that the longest side is our hypotenuse. So let's go ahead and see if this one is a right triangle. So I'm going to begin by writing out my formula. Leg squared plus leg squared equals hypotenuse squared, and my longest side here is 15. I'm going to substitute that into the hypotenuse. Okay, so 15 squared, and that means 9 squared plus 12 squared. And we're asking us, does 9 squared plus 12 squared, does that equal 15 squared? Well, let's go ahead and solve it. So 9 times 9 is 81. 12 times 12 is 144. Does that equal 15 times 15, which is 225? I'm going to go ahead and grab my calculator and add 81 plus 144. And that indeed does add up to 225. So 225 here equals 225. So this is a true statement. So that means that this triangle is a right triangle. So we just proved that since this follows the Pythagorean theorem, this triangle has to be a right triangle. Okay, let's look at another example. Once again, I'm going to begin by writing out my formula. Leg squared plus leg squared equals hypotenuse squared. And my longest side here is 9. So for hypotenuse, I'm going to substitute in 9. And that means I'm going to substitute 7 and 6 for my legs. Now we need to ask ourselves, does 7 squared plus 6 squared, does that equal 9 squared? 7 times 7 is 49. 6 times 6 is 36. And 9 times 9 is 81. Okay, I'm going to use my calculator to add 49 and 36. And I get that that equals 85. So does 85 equal 81? Obviously not. This is a false statement. So this is false. So that means this is not a right triangle. It's a fraud. It looks like a right triangle, but it's not a right triangle. You fraud. Oh, fraud is like not true. A scam. Scammer. Oh my gosh, that reminds me of one of my students. He would always say, scammers be scamming and this triangle be scamming. Okay, guys? All right. Sorry if I'm being cringy. Okay, so let's do one more example. Pause the video. See if you can do it on your own. Okay, I'm going to change it up. Change up my colors too. So I can have leg squared plus leg squared equals hypotenuse squared. I know that the longest side has to be my hypotenuse. That's 15. So I'm going to substitute in 15 for my hypotenuse. And that means that my legs are 10 and 10. 10 squared, that's 100. 10 squared again is 100. 15 times 15 is 225. 100 plus 100, that's 200. Does 200 equal 225? Nope. This is this again is a false statement. So this is false. So this triangle is a fraud. It is not a right triangle. Okay guys, I hope these 3 additional problems help you understand the converse of the Pythagorean theorem. I wanted to give you a few more problems to see other than the one from the Math Antics video. I hope you guys are having an awesome, what's tomorrow? Wednesday.